We're going to learn 4 theorems today. The first one is about the triangle proportionality theorem, and then we'll also learn its converse. The triangle proportionality theorem says that if I have this triangle right over here, okay, and it's intersected by 2 parallel lines like that. So if I have TU parallel to QS, then I can say that RT is similar to TQ and RU is similar to US. Okay, now like we did last time, you can totally separate out those triangles and then use proportionality that way. But the cool thing is, if you know these 2 lines are parallel, then even those partial segments are also similar. They create that same ratio. The converse, of course, says the opposite. If I know that RT and TQ are similar and RU and US are similar, then I can conclude that these 2 are parallel, right? So I'm basically looking and paying attention to those parallel lines. Let's do some examples and see how that works. So example 1 just says find AB. Now I see my 2 triangles that are overlapping, and I see that those 2 bases are parallel to one another. And since I know that, because of the triangle proportionality theorem, I can say that segment and that segment are similar, and this segment is similar to this segment. So I can use that same proportionality theorem at the top, and I can say that BC over AB equals CD over DE. Okay, and I just have to now substitute in my values because I'm looking for AB. Let's call that X for now. So BC is 7 over X equals 9 over 2. And then I just solve. It's just a regular old proportion. 9x equals 14, so x is equal to 14 over 9, which means AB is equal to 14 over 9. So just because of those 2 parallel lines, look at how much easier my job is. Now, if you didn't know they were parallel, you would have to take those triangles apart and solve it like we did on our last lesson. So find FC. FC is this right over here, so let me go ahead and call it X. And look at the information that I know. I know that this is going to be similar to this, and this is going to be similar to this, but darn, I do not have that value, right? So I'm missing 2 values. So what I'm going to do is go ahead and draw those triangles separately. Let me draw one a little bit smaller. We're going to call this ABC. This is 4, 6, 5. And again, this angle right here is right over there. And because I've got my parallel lines, these are corresponding angles, which makes them congruent to one another. So let me now go ahead and draw my bigger triangle. Again, that's A, C, oops, this was G, F. This is congruent to this one right over here. And I know that this is 10. How do I know it's 10? Because that's 4 plus 6 right over there. And our job is to solve for X. And you're like, okay, well, how does this help me? Well, it helps me because now I've got angle, angle. I can see that my triangles are similar by angle, angle. So now I can just set up my proportion like I've been doing. I can say 4 over 10 is equal to 5 over X. 4x is equal to 50, which means x is equal to 12.5 or 12.5, or you can say 25 over 2, which is what I am going to do. All right, let's do another one. This one is saying determine whether AB is parallel to XY. In order to be able to say that AB is parallel to XY, those two ratios do have to be equal to each other. So this over this has to be equal to this over this. And if it's not equal, then they are not parallel. So 7.5 over 5, is that equal to 6 over 4? Remember, I can do this lots of ways. I can simplify the fractions, or I can multiply like I do when I'm solving a proportion. That's what I'll do now. 5 times 6 equals 4 times 7.5. 30 equals 30. Check. So that tells me, yes, they are proportional. So I can say, yes, segment AB is parallel to segment XY because the sides are divided proportionally. That's all there is to it. Really straightforward. As long as you've got, if you know those sides are parallel, you can set up that proportion. Or if you know that the proportions hold, then you can say that the sides are parallel. Let's now do the back, where we'll talk about the three parallel lines theorem and the triangle angle bisector theorem. Okay, the three parallel lines theorem says if three parallel lines intersect two transversals, then they divide the transversals proportionally. So what this is saying is, here's my three parallel lines, and they're intersecting these two transversals right here. They intersect them proportionally, meaning this and this are similar segments. So it says UW over WY equals VX over XZ. That's similar to that, and that's similar to that. So let's go ahead and find the value of y. But again, first I need to make sure that my lines are parallel. If they're not parallel, this does not hold. So I see that I've got these congruent angles, which is great because I see that they're corresponding, and I know that if corresponding angles are congruent, then the lines are parallel. So I can say, okay, great. My lines are parallel. So these are now divided proportionally. So I can say 3 over 3.5 is equal to x over 9. And then I just solve. 9 times 3 is equal to 3.5 times x. So x is equal to 54 over 7, or 7 and 5/7, however you want to go about doing that. Let me move this down. That's it. And the final theorem for today is the triangle angle bisector theorem. And the triangle angle bisector theorem says if a ray bisects an angle of a triangle, then it divides the opposite segments whose lengths are proportional to the lengths of the other two segments. So what this is saying is I've got this ray right over here, and it's bisecting this angle right there, okay? These two segments are not congruent. I have noticed so many people, when they read the word bisect, they mark the segments congruent. You have to read what it is that's being bisected. The angle is being bisected, so the angles that are created are congruent. However, this theorem tells me that AD and DB, those segments are similar or proportional, and those segments are proportional. So example 5 says solve for the variable. Notice that this angle has been bisected. So I can set up my proportion saying these are similar and these are similar. So I can say x over 5 is equal to 9 over 15. And then I just have to solve for x. So x is equal to 3. All right, let's do one more, a little bit harder this time. So notice again, I've got a bisected angle right over here. My angle is bisected, which tells me that this is similar to this, and this is similar to this right over here. But the problem is I don't know that piece over here by itself. I only know the full value. But the cool thing is I know part of it. Remember, a part plus a part gives me a whole, right? So if I don't know this value right over here, I don't want to create a new variable. I want to use what I have. Well, if I want just that part by itself, I'm going to take the whole and take away the b. So this is going to be left as 14 minus b. And then I can set up my proportion. I can say b over 14 minus b is equal to 9 over 6.75. And then I have to solve for b. So 6.75b is equal to 9 times 14 minus b. And I distribute 9 times 14 is 126 minus 9b. Let me add 9b to both sides. And then divide. So b is equal to, believe it or not, 8. And that's it. The most confusing part about these is not getting your parts mixed up. So use your diagrams and match the question that you're given with the diagram in the theorem. And I promise you, you'll be able to set it up properly if you do it like that.